everyone, I'm Ashley.
Hi everyone, I'm Eng Ling.
In this video, we will be demonstrating how to determine the unknown concentration of a sample containing a mixture of compounds using the Shimadzu HPLC systems.
To determine the unknown concentration of a sample, you will need to have a set of standard solutions to set up a calibration curve. Ashley, some people may not be familiar with how to prepare a set of standards. How do you go about doing it?
Oh, that is a good question. This is something that we'll be focusing on in this video as well. We will demonstrate how to prepare the standards for external calibration in order to obtain a good calibration curve and accurate results.
The standard use contains a mixture of 5 compounds, caffeine and 4 different parabens. Caffeine has a maximum absorption wavelength of 273 nanometers while the parabens have an absorbance peak at 256 nanometers. The UV-vis detector or the photodiode array detector can be used to monitor the absorbance peaks at the wavelength of 260 nanometers. 260 nanometers is used for monitoring as the absorbance at this wavelength is sufficiently high for all the compounds. The solvent used to dissolve the samples is 50% methanol. The transparency of both methanol and water at 260 nanometers makes it suitable as a solvent. Standard samples of known concentrations are used to generate a calibration curve. In this demonstration, the samples used have concentrations ranging from 1 ppm to 200 ppm. They were prepared by extracting a portion of the stock solution and diluting it with the solvent as described in the table on the right. The system that we are using in this demonstration is the Shimadzu I-Series LC2050C3D, which has a photodiode array as its detector. Shimadzu's LabSolutions software is the interface used to conduct the entire experiment, from the real-time analysis to the post-run data processing. The column used in this demonstration is the Shimpack XRODS, with dimensions of 50 mm by 3 mm and a particle size of 2.2 micrometer. The mobile phase consists of water and methanol, which is programmed for a flow rate of 0.8 milliliters per minute and an isocratic elution at a concentration of 60% methanol. The oven temperature is set at 40 degrees Celsius and a volume of 10 micrometer of the sample is injected into the system. Starting from the real-time analysis window, create a new method file and set the instrument parameters to run the analysis and obtain data. This includes setting the parameters for the HPLC pump, such as the flow rate and mobile phase composition, as well as the PDA detector, column oven, and the auto-sampler. Download the parameters, then save your method file and start creating the batch file for real-time analysis. In the batch table of the new batch file, fill in the relevant details including the sample name and ID, data file name as well as injection volume. Then save the batch file and start the real-time batch run. The calibration curve is generated using the post-run tool of LabSolutions. After opening the post-run tool, open any one of the data files obtained in your real-time analysis. In the Edit mode of the method view, the data processing parameters can be set. The first being the absorbance wavelength of 260 nanometers that is used for monitoring. Under the Integration tab, the peak width and slope are used to set the selection criteria to detect and integrate peaks. The width refers to the peak width at half height. Under the Identification tab, the criteria to identify a peak in unknown samples when the data processing method is applied is set. Moving on to the Quantitative tab, the parameters used for quantitative analysis are set. This includes indicating whether an external or internal standard is used for calibration, specifying the number of calibration levels, the curve fit type and whether the curve should be forced through zero. The information of every standard sample is included in the Compound table under the Compound tab. This includes the compound name, retention time, and the concentration level of the standards. Save the parameters by clicking on the View button and save a new method file. Create a new post-run batch table and include all the relevant data files into the table. Ensure that the newly created data processing method file is used and that the sample type of the lowest concentration standard is selected to initialize the calibration curve. Also, ensure that the calibration level for each standard is indicated correctly. Save the batch file and then start the post-run batch run. Once that is completed, open the data file of the standard with the highest concentration. Under the Calibration Curve tab of the Results view, the full calibration curve can be seen. To obtain the concentration of the unknown sample, open the data file of that sample and go to the Compound tab of the Results view. The calculated concentration of each compound is displayed under the concentration column. In the next video, we will explain how a calibration curve is obtained when using an internal standard. Thank you for watching.